Hello and welcome to this section 7.3 lecture today for Algebra 1 Part 2. Today we're going to be talking about rotation transformations. We've talked about translations, we've talked about reflections. So we've talked about moving things and flipping things. And today we're going to talk about spinning things. We're going to go over pretty heavily the coordinate notation method because I will be honest in that I believe one of the harder transformations are these rotations. To really understand like where it's moving, things like that. And so is it going to be here? Is it going to be over here? I think an easier way to do that is to use these ideas of is to use the idea of the coordinate notation, like symbolically what's going on. Okay, so that's what we're going to focus on. But what it turns out to be is if I want to rotate a point 90 degrees, and the main rotation direction would be counterclockwise. That's kind of the traditional way. We're going to talk about both directions, though. So a 90-degree counterclockwise rotation. And again, for all these that we're going to look at, we're talking about the center being the origin, the place where the two axes meet. So we're talking about a 90-degree rotation around the origin. And they say it in words there, but it's multiply the y-coordinate by -1 and then switch x and y. Okay, that's kind of tough to remember. I don't think there's a great way to remember it. I would just write this down somewhere big and bold, and I'll look at a way to write it down and kind of help things out a little bit. So basically the point goes from xy to -y comma x. Okay, and so we see the point 5, 2 turns into -2, 5. Okay. Sorry, I'm having a hard time this morning. For a 180-degree rotation, we multiply that x and y coordinates by -1, so we get xy goes to -x, -y. Now, if you notice, that is the same thing as taking this point and applying the 90-degree rotation rule. So here's what I mean. If we take the point -y, x, that we've already rotated 90 degrees, so that's the result from this one. And then if I do that again, if I multiply the y coordinate, the one in the position of y, by -1, and then switch positions, that would turn into, I'll multiply the y coordinate by -1, so that's -y, -x, and then flip positions, I get -x, -y. Okay, so I know a lot of people that they just teach a 90-degree rotation. That's it. And if you want to get anything else, you got to get there from a 90-degree rotation. It's kind of a weird idea, but if you want to remember one of them, remember that one. And then if you have to do 180 degrees, do it twice. Do 290 degrees. And then there are some different things talked about for this last one. This is a 270-degree rotation counterclockwise. Or what some people would rather talk about this as, sure, it's 270 degrees counterclockwise. I would say a big or here, 90-degree rotation clockwise. Okay, it would be the same as a 90-degree rotation clockwise. Okay, so you should be able to understand that in either way. Sorry. Okay, I'll have to get to that a little bit later. So then to do that rotation, you can either take your 180-degree rotation and do the 90 rule again, Or I would say what's probably more common is to just know this rule. And it's to take xy, make the x coordinate negative or the opposite of the x, and then switch positions. So it's kind of the opposite of what we did up here. Or, like I said, you could take your negative x, negative y from the 180 degree rotation and rotate it 90 more degrees. So negative x, negative y, and make the thing in the y its opposite. And so the opposite of negative y is positive y. And then I switch positions. So y, negative x. Okay. All right, so let's go ahead and look at some of these. Okay, and again, I'm gonna mainly go with rules. That's what I'm gonna look at. So coordinate rules a little bit to make sure we can get these done. So a rotation 90 degree clockwise, that's going to be this one right here. Okay, also known as a 270 degree counterclockwise rotation. So basically, just to get an idea, is we're going to take it from here, 90 degrees clockwise, it's going to put it up here somewhere. Okay, I'm not sure where yet, but that's just my general idea so that I make sure I know at least where it should end up. So for that, all my coordinates are going to go from xy to y negative x. Well, let's look at how we're going to do that. I've got, let's start with k. I've got k at negative 5 and negative 3. So negative 5, negative 3. I want to switch positions and make the one in the x place its opposite. So negative 3, positive 5. Negative 3, positive 5. That's going to be k prime. For L prime, L is at negative 5, negative 5. And so we make the one in the x position its opposite and move it to the end. So we turn negative 5 into 5 and we move it to the end. So I have negative 5, positive 5. That's right there. And then this j at negative 1, negative 5. Will turn into, negative 1, negative 5. Will turn into negative 5, positive 1. So that was L prime. And then right there is J prime. Do your best, making some good lines. And there we go. Okay. Wasn't a question about what button I clicked. All right, let's look at the next one. We've got a 180 degree rotation about the origin. So we got 4 points this time, but my 180 degree rule is xy is going to negative x, negative y. So maybe we can do this a little more informally. Let's start with E. E is at negative 5, positive 3. So I flip both signs. Negative 5, positive 3 goes to 5, negative 3. That one's going to go right there. F is at negative 3, positive 5. Some symmetry there. Negative 3, positive 5. So it's going to go to positive 3, negative 5. So that's going to go right there for F prime. G is at 0, 2. So it's going to go to 0, negative 2. G prime right there. And D prime is at negative 4, negative 1. So it's going to go to 4, positive 1. D prime. And there we go. That is a 180 degree rotation about the origin. So when we talk about 180 degrees, it obviously doesn't matter if we go clockwise or counterclockwise. Don't get caught up on that idea. Okay. The next one here is a 90 degree clockwise rotation. So that's my very first one here. So that takes xy to negative yx. Get that down here. Xy turns into negative yx. And I'll do the coordinate breakdown for this one again, just to let us feel both methods. Let's go with t. T is at negative 1, 2. Negative 1, 2. Okay. So we switch positions, and the one that's in the y spot, we make that negative. Okay. One that's in the y spot, we make that negative. So that's going to be negative 2, negative 1. Negative 2, negative 1. That's my t prime. U prime, or u is at negative 1, positive 4. Kind of like picking on ones that are similar. These 2 points are a lot alike. It's going to turn into negative 4, negative 1. All right, that's not going to work out too good for me right there. T prime, negative 4, negative 1. That's U prime right there. V is all the way over here at 3, 3. And so we're going to turn that into negative 3, 3. Negative 3, positive 3. Neither of those are going to work out. I had a really hard time figuring out where this was going to end up. Yeah, I was afraid of that. Let me just move those all the way over here. I'll erase that point and put it back on there. Negative 4, negative 1. Okay, and then the last one, which one is that? That's V prime. And then my last one, W prime, is at 1, negative 1. And so that's going to turn into, take this one and switch its sign and move it in front. 1, 1. So W will turn into 1, 1 for W prime. And we try to not do it like that because that was terrible. Sorry. And there we go. All right, last one, 90 degree counterclockwise. So same rules apply. My x, y turns into negative y, x. All right, for me, that's going to mean that a point like W, let's start with W, I guess, at 0, 4 is going to turn into negative 4, 0. W prime. Point like V at 0, 5 is going to turn into negative 5, 0. U at 2, 4 is going to turn into negative 4, 2. And T at 2, 3 is going to turn into negative 3, 2. What do I got going on there? 2, 3, yeah, negative 3, 2. What do I got messed up? Something simple. 2, 4, negative 4, 2. I got this one messed up somehow. Okay, negative 2, 3. It's right here. That's what I was trying to do. So I had a hard time visualizing that one. Okay. So a big thing with rotations is obviously we're not killing the shape. We're not making it bigger, smaller, or anything like that. We're just changing its orientation and its location at the same time. Hopefully some of that made sense. Otherwise, make sure you write down any questions that you have, and then have a great day, and we will see you in class.